Hi everyone, I am Kamonphop Srisopha. Welcome to my presentation. Today I'd like to give an overview of my recent investigation, which my co-authors and I named it, Learning Feature that Predicts Developer Responses for iOS App Store Reviews. So I have divided my presentation into 5 sections. So due to the limited time to present, I will just gonna give you a brief overview for each section. So for so many years since the inception of the iOS App Store in 2008, the communication on the App Store has always been one way, with developers unable to respond to reviews directly. Fortunately, recently that has changed. The iOS App Store introduced a new mechanism that allows developers to directly respond to reviews right on the App Store. So developer can now provide guidance like in the example on the left. So in this example, developers provided troubleshooting steps for users. Or if user expresses the need of a new feature, but that feature has already been implemented, developers can quickly write a response to let the user know that the requested feature has already been implemented in the current version. And in the last example, developer can simply just show that they listened to the users. So recent study conducted on Google Play Store reviews suggested that responding to reviews can have a positive effect on user satisfaction. They found that users are more likely to edit their reviews after getting a developer response. And if users edit their reviews, they tend to increase the rating. So let's look at the review and response process in detail. So here on the left side depicts the user side. In this diagram, the user is composing a review. When the user finishes composing, they can click send. So on the right side depicts the developer side. When the user review is submitted, it will show up on developer's app management portal. Here, developer can see all reviews that the app received. They can read all those reviews and decide whether or not to respond to the review. So if they decide to respond, they can click the reply icon on the right side of each review. And this will bring up the text area where they can write their response to the review. So by looking at the process from the previous slide, we can identify 2 major pain points. On one side, for app that receives a lot of reviews, reading every single reviews and deciding whether or not to respond to them become a laborious process for developers. And on the other side, currently there are no existing guidelines for users on how they should write reviews in a way that would incite developers to respond when a response may be needed. So to address both sides, we need to answer the following 2 questions. 1, can we automatically identify reviews developers are most likely to read and to respond to? And if so, which characteristics of a user review developers use to decide whether the review will be read and responded? So to answer these 2 questions, we create a machine learning model to predict whether or not review will be getting a response. So the performance of a model can tell us the potential to automatically identify reviews developers most likely to read and to respond to. And by examining the learned relationship between review features and developer responses from the model, we can understand which characteristics of a user review influence developers' response to decision. So this is the overview of our research methods. It consists of 4 major steps: data gathering, feature extraction, model construction, and feature importance. In the data gathering step, we use our in-house crawling tool, which acts as an iOS device to collect reviews from the app stores. So in the feature extraction step, we extract feature from reviews both with and without developer response, and we will use this extracted feature as input to the step 3. So in the third step, we use the random forest algorithm to learn the data and predict whether a given review will receive a developer response or will not receive a developer response. The performance of the random forest algorithm is reported using area under the rock curve, or AUC, because it is insensitive to class imbalance. We report the metric with hyperparameter tuning and cross-validation by following prior work. So this step will help answer question 1. So in the last step, we employ a technique called permutation feature importance to assess the importance of each individual feature and groups of features to the model in the previous step. And this will help us answer question 2. So here's a summary of the dataset. We selected 8 popular free-to-download apps as case studies. So this app has a response rate ranges from 10% to 30%. So we ran our crawler to get all reviews and responses each app has over a period of 1.5 years. In total, we collected 113,000 reviews, and of those, 24,000 have developer responses. So the overall response rate is around 21%. So let's now look at a wide range of features we extracted from each user review. So these features are selected mainly based on features that prior work and related work identified to be associated with response decision. For example, responses in Q&A forum like Stack Overflow and responses in email communication. And we also focus on features that can be extracted by using tools that have been employed successfully in related work. So we group our selected feature into 2 top-level groups, non-text and text, and 7 lower level groups: rating, time, vote, sentiment, intention, style, and length. So let's now look at the results. So based on the results, we found that we can achieve an average AUC score of around 0.84. So the ROC curve on the left side for all apps generally stay away from the dashed line, which depicts a random classification model, which AUC of 0.5, so by large gains. So this indicates that the model, which uses the extracted feature, has high ability to capture the relationship between selected features and developer responses. So in general, we can observe that there's a potential or opportunity to further apply feature engineering and machine learning to help developers automatically identify reviews they are most likely to read and to respond to. So for feature importance analysis, we found that the 2 top-level categories, non-text, is more important than text features. For 7 lower level category, we found that rating is the top most important feature group, followed by the time group, which denotes the posted date time of a review, and then followed by sentiment group, and then the writing style and length. We found that the intention group did not contribute much to the model prediction. We also observed that the writing style as a group contribute to the prediction, like I said before. For individual features, we found that rating is the most important, followed by time after release, which denotes the time in hour that has passed between the release of a version and the posted time of the review for that version. So the 3rd most important individual feature is positive words body, which is the proportion of positive sentiment words in the review. So let's now look at one of the implications. For developer side, the benefit of this study is quite clear. We can develop a tool that could help identify reviews that developers are most likely to read and to respond to. So now let's look at the user side. The 2 examples shows a mock-up of a developer response prediction system. So based on multiple features that can be extracted during review composition, the system determines whether the user may need a developer response. It predicts the chance of getting the response and suggests steps to increase that chance. So on the left example, if it detects that a user is reporting an unexpected app behavior, but only describing the bug in 1 short sentence, it may suggest the user to increase the length by adding a more relevant information, which should increase the chance of getting developer response. So similarly, if it detects that the user is asking for help, it suggests to submit the review at a certain time of day to increase the chance of getting a developer response. So this system would serve as an evidence-based guideline on how to write reviews that will have an increased chance of getting a developer response. So this has the potential of raising the quality of user feedback. And of course, user should be able to turn these tips on and off in the setting for those users who think that this may be counterproductive or annoying. And the system should not review our high weight features, so to avoid user from gaming the system. So I will conclude my presentation with 3 key takeaways. 1, the benefit of understanding the key feature of user review that influence developer response decision is at least 2-fold. We saw 1 for user side, but developer side is also trivial to see. The second is we have shown earlier the efficacy of the random forest algorithm in predicting developer responses using the extracted features. So therefore, it is possible to create tools that can automatically identify reviews developers are more likely to read and to respond to. And lastly, we have shown that rating, posted time, sentiment, user writing style, review length can influence developer responses, whereas intentions and number of votes the review has do not influence the decision. And that's the end of my presentation. Thank you.